Hi and welcome to the new chapter where we will try to understand the internal implementation of a HashMap data structure. This happens to be a very frequently asked interview questions during the data structure interview round. A HashMap internally uses array, linked list and balance tree data structures for storing the key value pair. The HashMap data structure works on hashing principle or hashing algorithm where we use hash code and equals method to perform the insertion or deletion operation from the hash map. Here the hash code method is used to find the hash code of the key, which will be utilized to find the bucket or index position where a given key value entry will be stored. After we got the index position, the hash map calls the equals method to check if the value is already present or not. So if the value is already present in the linked list, then there is no need to store the key value pair. Otherwise, we will store the key value pair inside the linked list. See here we are trying to insert a key value entry into the hash map. So what will happen is we will call the hash code method on this key and will calculate the hash code of key 1, and using this hash code we will find the bucket position or the index position which will be represented by this array data structure. Say that the index position corresponding to key 1 is 1. So at this index position we will store the key value pair in the linked list. Now when we try to insert another key value pair, say key 2 and value 2, then we will find the hash code corresponding to key 2 and say this is also pointing to index position 1. In that scenario, in the next node of this linked list, we will store the second key value pair, that is key 2 and value 2. Similarly, when we try to insert key value pair x or y, or this key value x and value y, or key y value y, in both the scenarios we will find the hash code corresponding to key x and key y, and corresponding to them we will define the index position where this element or where this entry should go. In this scenario, the index position corresponding to both the key is 5. So we are storing key x and value x at one node of the linked list and key y value y at other node of the linked list. So this is how the insertion works. Okay. While the entry of the key value pair is more than a specific number, say 8, in that scenario the linked list will be replaced by a balance tree, which gives a better performance compared to a linked list. See here, the time complexity in case of the binary tree is big O of log n, whereas in case of linked list it is big O of n. So this balance tree is more convenient or more efficient in performance. So when we insert, say for example, key 1 value 1, key 2 value 2, key 3 value 3, key 4 value 4, say so on till key 8 value 8, a given specific number. So say for example all the key value pair is corresponding to the same index position. The hash code of all the keys like key 1, key 2, key 3, key 4 and so on till key 8 points to this index position. So then what will happen is at this index position we will store key 1 value 1, key 2 value 2, and we'll go on to storing key 3 value 3, key 4 value 4 till key 8 value 8. After key 8 value 8, if we want to insert key 9 value 9 and it is also pointing to the same index position, then this linked list will be replaced by a balance tree because it is better in performance. Now let's understand what is hashing collision. This is also very frequently asked during interview questions, where the interviewer might ask you to explain what is hashing collision in the internal working of HashMap. In that scenario you can explain that a hashing collision is a scenario where two or more keys have the same hash code. Then it results in a collision, which is also referred to as hashing collision. See this code snippet here, example here. We have taken a hash map which contains string as key and integer as value, And when we are trying to insert inside this HashMap instance a key value entry, that is Java and 10, so we will find the hash code corresponding to this Java key, and will determine which is the index position, and corresponding to that index position will store this key value pair. Now when we try to insert another entry with the same key, in this scenario both the keys will return the same hash code, which results in hashing collision. So in that case the value will be updated with the latest value. So 10 will be replaced by the latest value, which is 25 in this case. So when we call the get method on the key, we will get value as 25. Okay. So this is basically what is hashing collision. Now in order to retrieve any value, first the hash code of the respective key will be calculated, which will be helpful in finding the index position at which the key value entry might be present. Then at that particular index position, the key will be matched with the available key value pair, and the value corresponding to the matching key will be returned. So this is how HashMap works internally. Now in the next chapter, we will implement few important methods of HashMap data structure. So see you in the next chapter, and thank you for listening. Thank you.